This week we talk about atoms, those smallest kernels of matter that Democritus told us were indivisible. This is where we prove Democritus wrong. We break open atoms and we find out, we explore the clockwork mechanism that is the atom. You should understand the experiments of Rutherford, the gold foil experiment that really changed how we see the world. In many ways, the gold foil experiment changed the world around us more than the internet or the discovery of the telephone. This is an understanding of matter that's been here since day one, and we finally understand how it all works. The next section, the law of periodicity, is where we start exploring the differences between atoms. How carbon is different than nitrogen is different than oxygen. The key is protons. Every proton in the world has the same number of protons. Every carbon atom in the world has the same number of protons. And if it didn't, it wouldn't be carbon anymore. But understanding the makeup of these elements, we can start to understand their personality. Why nitrogen tends to form a 3- ion and why lithium tends to form a +1. We also start to lay these out, make flashcards and lay them out and build something called the periodic table. And the periodic table is the best cheat sheet you're ever going to have. The periodic table shows you how these different elements, these different fundamental components of matter fit together. You should understand what the periods are of the periodic table. There's 7 of them. You should also understand the rows of the periodic table, the families. Each row is a family, and like members of a family, they share properties. You should understand why oxygen is like sulfur. And for one thing, they both form a 2- ion, mostly. You should also understand the difference between the representative elements, those in the first 2 columns and those in the last 6. Those are the well-behaved elements. They're easy to predict. And then the transition metals, that area in between, they are not well-behaved. The transition metals are the wild, wild west of the periodic table. All the rules get broken in there. But you should be able to distinguish between metals and nonmetals, between metalloids, by their position on the periodic table. Next, we take apart the atom. We take a close look at each of those pieces that Rutherford helped us explore. We understand what makes something an ion by applying the plum pudding model to explain the existence of ions. We also start realizing the relative mass of these subatomic particles, how a proton and a neutron weigh about the same and an electron weighs way less than that. And as a result, we can start understanding the mass of these particles. And that's important. I mean, if you give a banker a pile of pennies, he's not going to count them. He just puts them on the scale and knows each penny weighs 2.5 grams. He looks at the weight, divides it by the weight, and tells you how many pennies. He counts it by the mass. The problem is, unlike pennies, atoms don't weigh the same. Carbon-14 is heavier than carbon-12. So what do you do when you got a bag full of carbons? You come up with the average mass. And the average mass of a carbon atom, or a copper atom or an iron atom, is how you weigh out atoms. It's how you count atoms. And this is going to be important because, well, if you pick up even a copper coin, it's going to have a tremendous number of atoms in them. But we need to know the moving pieces. We need to know how many atoms are in that coin if we're going to understand the chemistry that occurs. And just like a florist counts in dozens or a baker counts in dozens, we're going to count in similar quantities. But our quantity is the mole. 6.022 times 10 to the 23rd. That's 4 significant figures. It is a measurement. It measures how many AMU-sized things fit in a gram. So you should understand how to count by mass. The last part is using that atomic mass to apply stoichiometry, to answer that question of how many atoms are in a penny. Anyway, there's a lot of important stuff going on here, and some of this can get pretty complicated. If you get stuck, swing by office hours, shoot me an email, or just ask a question on the forums. At the bottom of each blog page, there's a link to forums where you can post questions and get answers, and anything is fair game. So if you have troubles on the homework or you're just confused about some of the reading, reach out and ask someone. We're all here to help. Hope you have a great week.